My name is Dr. Loy. I'm the acting chair of the Convocation Committee. Our job is to bring speakers to the university who bring areas of expertise or areas of interest that are not represented by our faculty. And we ask them to address big questions, big issues that might be related to some of the Q&I courses that you are taking. Today's speaker is Father Robert Spitzer. He has a rather impressive curriculum vitae, like a resume. I'm just going to read parts of it here. He is currently the president of the Magus Center. He's a member of the Society of Jesus, a Roman Catholic priest in the order of Loyola. I've forgotten his name, Father. St. Ignatius Loyola. He has several master's degrees in philosophy and theology, as well as a PhD in philosophy of science from the Catholic University of America. He taught philosophy at several universities, and then for 11 years served as president of Gonzaga University in Washington. He's published widely in the philosophy of science, metaphysics, and business ethics. I'm not going to try to count the articles, but he tells me that he's published 11 books, so he has been a prolific author. Will you please join me in welcoming Father Spitzer to the stage?
Well, it is a real honor to be with all of you today, and I thank you for coming out on a beautiful, about to be rainy day. I'm going to just be discussing this whole area of faith and science for a minute, and with the preface that today we can know more about faith and science than in any other time. I know that's not the impression that sometimes is given in the popular media, but in fact it is the truth, and I'll be trying to give you some very, very good references and books that you can go back to and refer to as you do some of your own research if that interests you. I'm just going to begin with the topic of whether science can disprove the existence of God. The answer, even though the popular media might suggest otherwise, the answer is no. It's impossible to do by the methodology of science itself. So just remember the following three thoughts. Number one, every bit of evidence that we get in science has to come from observational data. You have to be able to observe it, either measure it, observe it, use an experiment to make an observation. But if you don't have observational evidence, you don't have science. You have something else. Second point, all observational evidence has to come from within the universe. So we have no way of accessing anything outside of the universe. In fact, we don't even have a way of accessing information or observational data beyond what we call our event horizon within the universe. So basically, any kind of information outside of the universe can't be observational data for us, and therefore it cannot belong to the methodology of science. Third point, God is outside the universe. This is a fact. If God is the creator of the universe, then the universe can be a thought in the mind of God, in a super intelligence, which we'll talk about a little bit later. But you cannot have, God, as it were, being restricted to the observational horizon within our universe. That's contrary, as it were, to the definition of God. So the first thought is, hey, wait a minute. If all scientific data has to come from within the universe, then how can you disprove a God who is outside the universe by using observational data? The answer is you can't. It's impossible. It's no more possible to do that than to have a cartoon character assemble all of the evidence from within the cartoon to disprove the cartoonist. It's impossible. Can't do it. Second thought, for a long, long time, and what I'm talking about is almost 2 millennia, there was a thought that time was infinite, that time progressed backwards for an eternity, for an infinity. And this was held, by the way, by very famous philosophers and theologians in the Christian church, not the least of which were, St. Thomas Aquinas, et cetera, et cetera. But that changed with a Roman Catholic priest in 1923. The man's name was Father Georges Lemaitre. Many of you who study physics probably have heard of Lemaitre-Walker spacetime, or have heard of the Lemaitre function or equation, or the Lemaitre constant, or other kinds of things. Father Georges Lemaitre was a physicist. He did his doctoral work at MIT. He was a colleague of Albert Einstein's. And he discovered an explanation for what was called the excessive recessional velocities of extragalactic nebulae, which is just an easy way of saying the galaxies which are further away from us are accelerating away from us faster than the ones nearer to us. And that led to a real difficulty. How in the world can this possibly be explained? Well, Lemaitre explains it through the general theory of relativity by just simply saying, well, maybe the universe as a whole is expanding almost like a balloon, if I might put it that way. And it's really not the galaxies moving away from one another in fixed space. He suggested that the space-time continuum itself was expanding, meaning that the universe itself was expanding. And in 1923, he proposed what became known after Fred Hoyle renamed it, the Big Bang Theory. And the Big Bang Theory today is the most comprehensively tested, the most comprehensive universal picture that we have of physical reality, certainly that we have of our universe. And it still remains the same. Yes, we have modified Lemaitre's theory. We put a lot of things into it like inflation and quantum gravity and all kinds of things. But at the end of the day, Lemaitre basically changed the picture of the universe. Because according to Lemaitre's theory, and this was validated later by the Hawking-Penrose singularity equations in 1968, but a long time later, but the fact is, if general relativity does proceed back to something fundamental like a singularity, then you're going to have a beginning of the universe. And so Lemaitre pronounced, he said, well, there was a day before which there was no yesterday. There was literally a first moment of creation prior to universal expansion. Now, that changed the entire picture of physical reality. I won't get into this because it's not a history of science lecture. I really want to talk about the evidence for God from science in this talk, but the point I'm trying to get to is once that picture changed, it never really went away. By the way, there's excellent validation of the Big Bang Theory. We know with real certainty from the Planck satellite, the WMAP satellite, the two COBE satellites, Hubble's, redshifts, his survey of the heavens, the discovery of the 2.7 degree Kelvin uniformly distributed radiation. We are very sure that approximately 13.8 billion years ago, plus or minus 100 million years, our universal expansion began. Now, that fact is so clear, you're not going to get away with anybody denying it, at least in the scientific community, as a matter of scientifically established fact. It's as established as you're going to get it. So what has been the way of getting out of what seems to be a beginning of the universe, and we'll talk about why a beginning is so important in a moment, but what have been the ways of trying to get out of that beginning of the universe or beginning of physical reality? 4 major theories have been proposed. Number 1 is called the bouncing universe theory, or the so-called oscillating universe theory. That's where our universe didn't have just one expansion. It expanded, then contracted, re-expanded, recontracted, and theoretically, it could have proceeded back eternally. So that seems to avoid a beginning. But as we shall see in a moment, contemporary physics does not validate the bouncing universe theory, not at least eternally bouncing theories. You might be able to have a bounce, but if Willy Fischler and Thomas Banks are correct, it'd turn into a black crunch, and the black crunch would mean a state of thermodynamic equilibrium or pure entropy, where the universe would not be able to do anything after it receded back into a state nearby a singularity. So the key thing that we want to remember is that right now, we shall see in a moment, the eternally bouncing universe theory is not going to work, and it can't be validated in physics, and so that's going to imply a beginning. The second big theory that came out, sort of replacing the bouncing universe theory, was the multiverse theory. And the multiverse, as we shall see in a moment, is very, very seriously challenged today by what we call Boltzmann brains and brief brains, but I'll talk about that in a moment. But a multiverse is a huge mega universe, right? It's like this, universe of universes. And it's constantly sort of burping out little bubble universes. And there's trillions upon trillions, according to the hypothesis. There's no proof of this. But according to the hypothesis, there would be trillions upon trillions upon trillions of little bubble universes that are bouncing out of there, and that are burping out of there. And one of those bubble universes is our universe. So that would make our universe one amidst, trillions upon trillions upon trillions of bubble universes. And theoretically then, even though our universe would have to have a beginning, and all the other bubble universes would have to have a beginning, the multiverse itself, theoretically, could avoid having a beginning. But as we shall see in a moment, the Bdg and Guth proof, as well as the brief brain and Boltzmann brain problems, pretty much invalidate that as an explanation. Again, suggesting seriously that the universe had a beginning. There's a third theory that has come out, and it's in light of what's called quantum gravity or quantum cosmology, and this is basically higher dimensional space universes. So in what's called M-theoretical universe, you could have maybe 2-3 dimensional brains, and in this higher dimensional space with 11 or more dimensions in it, right? And sandwiched between them is a 4-dimensional bulk space-time. So these two, membranes, these two 3-dimensional membranes are colliding in the 4-dimensional bulk space-time and burping out additional universes, or nucleating out additional, little mini-universes all the time. So maybe our universe had to have a beginning. It's one of the nucleations, in this higher dimensional space universe in string theory, right? But basically, the higher dimensional universe itself could proceed back eternally. And then there's another one called the infinitely static universe hypothesis, where prior to our universe's, expansion, essentially the universe was around for an infinite period of time in a state of perfect equilibrium, perfect stability, no metastability whatsoever, and then one day it just explodes, right? And that would have been 13.8 billion years ago. And so maybe that universe could have lasted for an eternity. As we shall see in a moment, again, doesn't seem to be the case. Too many problems with the universe in that state, especially the fact that it's a contradictory hypothesis. So every one of the hypotheses so far that we have that's tried to extend, the universal time or the time of physical reality prior to the Big Bang, prior to the expansion of our universe, every single one of them still strongly implies a beginning. But of course, I've gotten ahead of myself. We have to get to, well, what's the evidence that these four areas, strongly imply a beginning? And what's even further the evidence that there would have to be a designer, that there is significant fine-tuning in our universe, somehow implying transcendent intelligence or even a designer. As you can see from this little, by the way, some of the figures that I'm referring to, that was Father Georges Lemaitre there with Albert Einstein. When Lemaitre told Einstein his theory, Einstein said, "Wow, the mathematics is terrific, but the physics is ridiculous." imagine a universe expanding as a whole from its very inception. Well, in 3 years after, in 1927, after Hubble had completed his survey of the universe, Einstein went up to Mount Wilson with Einstein and showed Einstein the fact of the recessional velocities of the expanding galaxies, according to the Lemaitre formula. And Einstein went back to Lemaitre and told him, this is the most satisfying explanation of creation that I have ever heard. So I think what we're dealing with here is we're on the brink, as I'll say in a moment, of a real point at which science is not pointing in any way away from God, in any way away from a transcendent intelligence or a trans-universal, trans-physical intelligence. In fact, it's pointing to it. And the preponderance of evidence would be there. Let's get to this back upside-down triangle here. I just want to talk about 3 kinds of evidence very, very quickly with you. What I can do in 45 minutes is going to give you the blitzkrieg. But I want you to remember, I'm begging you to remember a website to go back to if you want to get the full explanation for these things. I'm going to give you 2 websites. The first one is called magicenter.com. There's a ton of free videos, a ton of free articles. If you just go to the Faith and Science page, it's all there. I'm going to talk very briefly about the Bdg and Guth proof. I'm going to be talking about the entropy evidence, but I don't have time to go into this in detail. If you guys are the equation types, if you want all the equations, you want the articles in which this appeared in physical review letters or whatever, then go back to these free articles and free videos on magicenter.com. That's M-A-G-I-S center.com. There's another one called crediblecatholic.com. I know I'm in a Lutheran establishment, but I assure you that the science is perfectly acceptable to my good Lutheran father and my good Jewish grandfather, as well as my good Catholic mother. So it's good science. So let me get to the point, at hand here. And the first, of course, is we can tell the beginning of a physical system by some of its properties, or what we call intrinsic characteristics. And one of the ways in which we do this is with what we call space-time geometry proofs. So we can postulate, for example, if X, Y, Z holds for this multiverse, or this universe, or any multiverse, then that universe or multiverse would have to have a beginning. So we do have all kinds of space-time geometry proofs. Now, there were the kinds that were what we call pre-inflationary space-time geometry proofs. That would be like the Hawking-Penrose singularity equations from 1968, etc. And then there's the post-inflationary space-time geometry proofs. And I'm just going to concentrate on those because it updates the Big Bang Theory, accounts for the multiverse and other kinds of things. We have one of the space-time geometry proofs that's was very well known, was done by Arvind Borda and Alexander Vilenkin. And this particular proof, going all the way back into the 1990s, actually had 4 conditions. So if X, Y, Z, and A are true, then any universe or multiverse would have to have a beginning. There was a loophole in that particular proof, and by the way, Arvind Borda was in the Kavli Institute there at the University of California, Santa Barbara, and Alexander Vilenkin was the head of the director of the Institute of Cosmology at Tufts University in Boston. And so there was a loophole in it for some very, very highly improbable suggestions for our universe or a multiverse from which it could have spawned, but it nevertheless was a loophole. But in 2003, another fellow joined their crew, and that was Alan Guth, who had the chair of cosmology at MIT, Massachusetts Institute of Technology, and he joined Arvind Borda and Alexander Vilenkin, And they put together what's now called the board of the Lincoln and Guth proof, or the Bvg proof. Now, the Bvg proof, or the Bvg theorem, is a pretty easily explained theory in 6 steps. I don't have the time to explain it to you right now, but maybe during the Q&A we can talk about the 6 steps very, very briefly. But again, go to the moduscenter.com site and just click on the Faith in Science or the Evidence for God from Physics article, and there you'll get all the 6 steps explained to you. Here's the significance of the Bvg proof really quickly. Number 1, it only has 1 condition. That's better than 4 conditions. If you have 1 condition, it's much harder to disprove than if you have 4 conditions for the proof or the conclusion to follow. So the key thing to think about here is the 1 condition is easily met. If the universe or multiverse has an average expansion rate greater than 0, what we would call the Hubble expansion. So if a universe or multiverse as a whole has an expansion rate greater than 0, an average expansion rate greater than 0, if you're talking about a bouncing or oscillating universe, then that universe or multiverse is going to have a beginning. Now, this is a very elegant proof, and there have been no shortage of attempts on the part of the physical community to try and disprove this, but none have worked. Since 2003, this proof has just stood out. And not only applies to our universe. Obviously, our universe is an inflationary universe. It obviously has an expansion rate greater than 0. But it also has to apply to every bouncing universe. Every bouncing universe, insofar as it starts off in an expansive condition, that bouncing universe will have to have an average expansion rate greater than 0. And by the way, it must apply to every multiverse. You can't have a multiverse without inflation. Every multiverse must be inflationary. That means have an accelerating expansion rate. And an accelerating expansion rate certainly fits the condition for an average expansion greater than 0. So by definition, according to the Board of Lincoln and Guth proof, every multiverse must have a beginning. No exceptions, because every multiverse must be inflationary. And by the way, every higher dimensional string universe also has to have a beginning, because every higher dimensional space universe which is nucleating from a smaller core to a bigger core, and every time a nucleation takes place, it's in an accelerating state relative to the previous nucleation. So you're always going to have in a string universe an average expansion rate greater than 0. Uh-oh. What does that mean? Well, right now, what it means, and we seem to have no other explanation for it, is that every known cosmological configuration of physical reality, whether it's our universe or some reality much greater like a multiverse or a string universe, every single one of them implies or entails a beginning, prior to which there was no physical reality. Let me spell that out. Prior to which physical reality was nothing. Just hold on to that for just a moment. There's a second kind of evidence from entropy, and I just want to talk about it really quickly. Entropy is different from the Board of Lincoln and Guth. It's different from the space-time geometry proof. Entropy basically talks about the universe is moving from a state of what we might call order to disorder. Every time physical activity is done, the universe, which has a whole lot of order compactified into it from its very inception, It's moving progressively and in the long term, irreversibly, to a state of disorder. Now, if a physical system is disordered, completely disordered, what we would call thermodynamic equilibrium, it can't do anything. It can't accomplish anything. It can't be giving rise to stars. It can't be giving rise to planets. It can't be giving rise to all kinds of physical reactions. It can't even sustain physicists thinking about it. For all intents and purposes, a completely disordered universe, a universe in total entropy, a universe that's in a state of thermodynamic equilibrium, is a universe that can do nothing. It is what we call a dead universe. But our universe is far from dead. And by the way, any multiverse which could be spawning our universe is far from dead. I have an extensive discussion of this in an article I just finished for this little debate book called Theism and Atheism. I wrote the article on fine-tuning and indications of transcendent intelligence in that book with physicist James Sinclair. So the main point that I want to get to, though, is entropy also indicates not only a beginning of our universe, but very likely indicates a beginning of all multiverse systems. There are some people like Sean Carroll who have been trying with all their might to get out of a multiverse being entropic, but as I make clear in other articles, it's very difficult to get out of entropy. As Einstein once put it, all of the physical laws of our universe that have been discovered up to this point may well change except one. The second law of thermodynamics, entropy, because it is not based on physical conditions alone. It is based on statistical and probabilistic properties intrinsic to all physical conditions. And so, as I would point out, there seems to be two major evidence sources, two major ways in which we know that the universe, not only our universe, but a multiverse, and also a string universe, and every other known physical configuration of our universe would have to have a beginning. Now, why is this so significant? It's significant because of two things. Number one, a beginning in physics, a beginning of physical reality implies a transcendent power outside of physical reality. Let's go through the 3 steps of this proof. Step number 1. If you have a beginning in physics, then there was a point before which physical reality did not and could not exist. So a beginning implies a point before which there was no before which there was no physical time, before which there was no physical energy, before which there is nothing physical. Nothing physical. In fact, there's not even physical time. So there's no before. So this point is very important. Why? Point number 2. Because at that point, physical reality itself, including physical space and time, is nothing. Point number 3. Nothing is nothing. Don't sneak something into nothing. If you sneak something into nothing, you have what's called an equivocation. What we really mean by physical reality is nothing is that it's nothing. That means it's not the laws of gravitation. That means it's not, right, a very low energy condition in a physical system. It means it's nothing. Now, what is the only thing that nothing can do. Nothing. Because it's nothing. Point number 3. If at one point all of physical reality was nothing and could only do nothing, then it could never have moved itself from nothing to something, because it could only do nothing because it was nothing. Conclusion. Therefore, there has to be something outside of, beyond physical reality itself, which can move our universe or move physical reality from the state of nothingness to something. And that transcendent, transphysical reality might justifiably be called a creator. So at this point, it seems that there is a strong implication of a creator from the current configuration of our universe, including all of the so-called pre-Big Bang configurations, multiverses, string universes, a strong implication of a creator from a beginning of those conditions. Let me give you Alexander Vilenkin's, sort of a paraphrase of Alexander Vilenkin. He's the V in the Bvg Proof, the guy who's the director of Institute of Cosmology at Tufts University. Here's the way he put it. It is said that a good argument will convince a reasonable person, and that a proof will convince even an unreasonable one. Well, now that the proof is in place, what proof? The Bordova-Vilenkin and Guth proof combined with the entropy evidence. Now that the proof is in place, cosmologists, and cosmologists are physicists who are looking into the beginning of the universe or into very, very fundamental universal or physical conditions. Now that the proof is in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They must confront the reality of a beginning. And inasmuch as a beginning of physical reality implies some kind of transphysical cause of that reality, then it also implies the existence of a creator. That's all I'm saying. This is where we seem to be right now. But we can know more from the vantage point of physics. There's a lot of fine-tuning evidence that's out there. Now, I know people will say, well, fine-tuning arguments, that was all disproved by Victor Stenger's book, The Fallacy of Fine-Tuning in 2011. No, it hasn't. If you guys are really interested in the physical explanation of this, I'm begging you, please go to your Google tonight. Go to an article by Luke Barnes, B-A-R-N-E-S, and it's called Indications of Design in the Universe. He basically disproves the entire Victor Stenger thesis. First of all, he shows that there's the fallacy of equivocation in Stenger's central argument. He then goes on to show that if you actually held to Stenger's thesis in physics, you would wind up denying about 7 of the major hypotheses and theories in physical reality, and then goes on to show the objective basis of fine-tuning. So, Barnes has definitively responded to the Stenger book, and I don't think you have to worry about that, but it's all free of charge on Google. Just go to Luke Barnes and just go to his thing on intelligent creation. I'm also on indications of intelligence or intelligent design in our universe. There's a second book I'm also going to recommend, and that is a book by Geraint Lewis, L-O-U-I-S, and this other fellow again, Luke Barnes, called A Fortunate Universe. A Fortunate Universe. If you are interested in what I'm about to talk about, you have to get this book and just read it. He really puts it on a layman's level, right? He is a physicist, of course, at the University of Sydney, and so is Drayton Lewis. But the fact is that they really make attempts to make the physics intelligible to an ordinary person. Let's just get to a few thoughts about fine-tuning arguments, because they imply that this creator we just talked about, outside of space and time, outside of our universe, outside or beyond physical reality itself, is also intelligent. So first of all, we have two kinds of proofs, but I'm not going to get into the whole thing. I'll just simply say this. There are certain conditions that are required for any life form to exist. For any complex life form to exist, you have to have certain conditions met. Point number 2. The odds of those conditions being met are exceedingly improbable. Therefore, you only have two choices. Either the universe got these conditions through a multiverse, or the universe got these conditions through a very intelligent force outside of our universe, literally instilling them into the universe itself at the Big Bang. Now, physicists approach these kinds of arguments in a very different way than biologists do. Biologists are looking at, can you justify, the movement from, point A to point B in an evolutionary progression just with scientific laws alone. Physicists don't do it that way. They just simply look at what do you need even to have an evolutionary process? What do you need in order to get just a single-celled metabolizing organism? What are you going to need in the physical universe? What kinds of constants are you going to need? And then they just judge the probability or improbability of those constants occurring by pure chance at the Big Bang. And that's got a good, solid basis, and I'll tell you why it does. Because the Big Bang is a fissure. The Big Bang is a boundary. It's a boundary between, cause and effect. There is no causal relationship between what happened after the Big Bang and what theoretically could have happened before the Big Bang. The singularity and even the bounce literally break down the cause-effect relationship even in a continuity of time. This is important because if you can't find a natural explanation in our universe, you can't appeal to a prior natural cause if this occurrence took place at the Big Bang. And that is what makes these proofs so strong. Let me just give you a few examples, get to the multiverse, and call it get ready for your questions here. The first thing that I think is really key when you're dealing with these arguments is there's one argument that is really, really vexing for every physicist. It was articulated by Roger Penrose way back in 1998 in The Emperor's New Mind. But what it is the odds against low entropy in our universe. I'm just going to give you this, and you can read about it on MajaCenter.com or wherever you want. But here's the thought. Low entropy, that means high order. Low entropy or high order is really necessary in order to have a life form develop. You can't have a life form if your universe is a high entropy universe. Now get this, everyone. So Penrose, by the way, very, very famous physicist, one of probably the top 10 physicists, and he's at Oxford University, calculated the odds against a low entropy universe occurring by pure chance at the Big Bang. You want to know what it is? The odds against it are 10 raised to the 10 raised to the 123 to 1 against. That's a double exponent, ladies and gentlemen. That basically, if I were to put that number out, it'd be 10, and then in a single exponent, it'd be a 1 followed by 123 zeros. The exponent is a trillion, 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 trillion. That's the exponent. If you put that number in 10 point, with every zero being 10-point type, that universe would not fill up our solar system. I mean, it would fill up our solar system. It'd exceed our solar system. It's the same odds as a monkey typing the entire corpus of Shakespeare. The entire corpus of Shakespeare by random tapping of the keys in a single try. Highly improbable. Now, this is where we stand today. Penrose has been unable to explain it. No one has explained it. I mean, fine-tuning conditions, cry out for an explanation. This particular one of Penrose, the low entropy universe necessary for life forms, screams out for an explanation. How in the world did this occur by pure chance at the Big Bang? There's only two possibilities. Either there was a multiverse that did it, or, right, so it occurred, right, one of the trillions upon trillion upon trillion upon trillion upon trillion of bubble universes, one of them was like our own, and so you postulate a multiverse of trillions upon trillions of universes, and you get yourself a good, you get one out of every 10 to the 10 to the 123 bubble universes. That's one possibility. And the other possibility is a real smart God. Take your place, a real smart creator. Infuses the low entropy condition into the universe at its inception. There's not a lot of other explanations that are going to work. Here's the point at hand. And by the way, this is very well articulated by Luke Barnes and Geraint Lewis in that book, Fortunate Universe. The point is, if there's something wrong with the multiverse, if it falls short as an explanation, you're looking straight into the possibility of an intelligent designer, an intelligent transphysical designer. More on that in a moment. Let me just give you a few other quick examples, and then we'll go ahead and take your questions and look at the multiverse. Take your questions. First, there are about 20 cosmological or universal constants, and these constants have to be set at the Big Bang itself. What's a constant? A constant is a number that is affecting the equations of physics. It affects all the outcomes of the equations of physics. It basically, every number that's a constant is determining what kinds of outcomes you're going to have in all of your cause and effect relationships. All the space-time outcomes, all the quantitative outcomes, all the interrelationship outcomes, all the interaction outcomes. Every causal outcome will be determined by these numbers. Some of them you probably already have heard of. You may have heard of, well, you certainly heard of Lemaitre's constant, which is now today called Hubble's constant. You probably know that there are four forces in our universe, right? There's the strong nuclear force, the electromagnetic force, the weak force, and the gravitational force. Well, each of those forces has a constant, or more than one constant attached to it. So, for example, the gravitational force has the gravitational force constant. The electromagnetic force has three constants: the mass of the proton, the mass of the electron, the electromagnetic constant. The strong nuclear force has the strong nuclear force coupling constant. And the weak force, I got it, and the weak force has the weak force constant. I'll wind this up very quickly. Now, here's the point I'm trying to make. You cannot alter, though, any of those 20 constants. You cannot alter them even one little micro, nothing higher or lower than the values they just happen to have at the Big Bang. Because if you did, life would be impossible. Just a couple of examples. Example number one, if you altered the weak force constant or the gravitational force constant by only 1 part in 10 to the 50th, that's a very small fraction. That's a decimal point, 49 zeros, and a 1. Higher or lower than the values they just happen to have at the Big Bang. 1 part in 10 to the 50th, higher or lower than the values they just happen to have at the Big Bang, either the universe would have been exploding continuously in its expansion, which would have fried every possibility of every life form, or the universe would have collapsed into a black hole, where the entire mass density of the universe would be collapsed into 10 to the minus 33 centimeters, with almost infinite crushing capacity, exceedingly bad for the development of life forms. What's my point? You lose either way. You mean we have a complete cosmological disaster by a mere 1 part in 10 to the 50th in the weak force constant, the gravitational constant? Yep, that's exactly what I'm saying. Do you know the odds of the gravitational constant, weak force constant, relative to one another getting these values that they just happen to have at the Big Bang by pure chance? Yeah, got it. Monkey typing Shakespeare, same thing. Just take 2 more examples, get to the multiverse, and we'll be done. The second, just another example is if you altered the electromagnetic, we've got the mass of the proton, the mass of the electron, and the electromagnetic charge. If you just altered them by 1 part in 10 to the 39 relative to the gravitational constant, then every single star in our universe would have either been a blue giant or a red dwarf. If every star in our universe was a blue giant, everything would have been fried. Very basically bad for the development of life forms. Alternatively, if you had made that just 1 part in 10 to the 39th lower, then every single star in our universe would have been a red dwarf. Not enough energy to bring any temperature above, absolute freezing. So essentially, we're either frozen or we're frying by 1 part in 10 to the 39th in those 3 constants relative to the gravitational force. What's my point? The odds against this happening at the Big Bang by pure chance are like monkey typing Macbeth. What's the point of it all? There are a lot of fine-tuning coincidences out there, and I could list a lot more, and I do. Barnes and Lewis do the same thing in their book, Fortunate Universe. You can read about these things, but we're left with only 2 hypotheses. I don't have time to go into it because right now the shortness of time, but you're left with the multiverse, and you're left with essentially the intelligent transphysical cause or the intelligent creator hypothesis. And you can take your pick, but I'll tell you this. The multiverse hypothesis has 4 basic difficulties. The first 2 are really not difficulties. Every multiverse has to have a beginning, so we know that there's not going to be an infinite number of these bubble universes. Secondly, the other thing that's of key import is that it contradicts what's called Occam's razor, the canon of parsimony, where nature tends to favor elegance. But in this particular case, you have to postulate a trillion bubble universes in order to explain just one, our own. So it seems to be a violation, but that's not really a problem. Here are the big problems. The Boltzmann brain problem and the brief brain problem, which I do not have time to go into today, basically preclude the multiverse as being a realistic hypothesis. And there's a good deal of literature on this. Geraint and Barnes have a very good explanation. In the book Theism and Atheism, I have an explanation there of the same thing. But the Boltzmann brain problem and the brief brain problem are completely vexing. Essentially what it means is you're not who you really think you are. If you live in a multiverse, you guys, you are just thermofluxed brains that have popped into existence for a mere second out of a complete flux of energy, and you got all the memories that you have of thinking that you're living with all the people you're living with, and packed with all the time thoughts you have. The odds against you being who you really are versus being a Boltzmann brain are almost infinitely greater if you have a multiverse in the sense described by some of the current theories. Basically, if the multiverse is true, we're either a Boltzmann brain or a brief brain, but in either case, we're not who we think we are. And if that doesn't invalidate your hypothesis scientifically, then I need to see you afterwards. The last thought is every single multiverse hypothesis that we have today requires fine-tuning itself. We don't have a non-fine-tuned multiverse hypothesis. You're going to have very, very special conditions, very low entropy, written into the initial conditions and constants of the multiverse itself. So what winds up then that the multiverse is not a complete explanation. The multiverse is basically moving the whole process back one step. So I just leave you with two quotes to conclude this lecture that sort of basically sum up the position that there is a high likelihood, in my opinion, from current scientific evidence, that there is a transphysical cause of physical reality which is highly intelligent. If we're to avoid brief brains, Boltzmann brains, if we're to adhere to the Bdg and Guth proof and the entropy evidence, et cetera, I think it's a very, very good possibility, good, even probable, that we have a transphysical intelligent cause out there. Here's the point from Fred Hoyle. Fred Hoyle was the great atheistic gadfly of the physics community for decades. Well, one day, his partner, William Fowler, came into him and basically said, "Oh, Fred, there seems to be a problem here. I was just taking a look at the odds of having the correct resonance levels for beryllium, oxygen, carbon, and hydrogen in order to get an abundance of carbon in our universe." And Fred said, well, what's that? And so he goes and he looks at the odds, which of course are billions, again, billion, to one chance against this thing happening. And he came out, and this is basically his quote that I leave you with. He said, I do not think that there are any blind forces worth speaking about in nature. This is the former atheistic gadfly. There are any blind forces worth speaking about in nature. It seems to me that there must be some super-calculating, super-intellect that has monkeyed with the constants of physics and with those of chemistry and biology as well. I consider this to be beyond the shadow of a doubt. There was a great astronomer who also postulated, a beginning of the universe. He was the founding director of NASA's Goddard Institute of Space Studies, Dr. Robert Jastrow. He put it this way: science unshackled itself from the domain of superstition and began to climb the heights, to scale the mountains of knowledge using an empirical apparatus and mathematical deductive reasoning. And finally, when they came to the last precipice and pulled themselves over, the scientists discovered a band of theologians there awaiting them for centuries. Thank you so very, very much.
My question is, because you've been bringing up all these arguments about anthropic fine-tuning and everything like that. The thing is, though, I've been listening to this, and I have one question to ask.
Sure.
Even if these do act as 100% solid proofs of a creator, how could you then also, by extension, prove which specific one? Because so far, these proofs sound like they could apply to any creator deity, not just the one of the Bible.
Yeah, it actually could apply to any transphysical creator. Exactly. It wouldn't prove, for example, a Christian God. And of course, that's the problem with science, or the problem even with philosophical proofs for God. I mean, the most that a scientific proof can do is to show, a transphysical intelligent creator. Is this creator a moral agency or a non-moral agency? Now, we might be able to infer, from our own moral standards that the creator is a moral agency, but we don't know from science. You can't tell that from science. Similarly, in philosophy, you can actually prove, and if you go to that website, manjacenter.com, you could actually prove that there exists a unique, unconditioned, unrestricted, continuous creator of all else that is, which is an unrestricted act of understanding itself. You could prove that. Now again, we have a whole load of questions that logic and rational evidence or scientific evidence cannot establish. So this only establishes the groundwork. So what are some of those questions? Does God redeem suffering, or does the Creator redeem suffering, or does He not redeem suffering? Is He a good God, or is He a bad God, or is He kind of a mix in between, the good side of the force and the bad side of the force? Is the Creator, does He have an interest in human beings, or is He like Aristotle's God, bored to tears with sub-intellects like ourselves? Similarly, is God guiding us, inspiring us? Does He, redeem our suffering? And is there an eternal salvation for us? I mean, we could find some ways of trying to reasonably establish this from our own desire for, to live on, or from our own moral standards. But essentially, it's beyond science and beyond philosophy. You'd have to start taking some inferential leaps of the heart in order to do this. And of course, at the end of the day, the only way you're going to get a definitive explanation, honestly, is if you believe in the source of God's own self-revelation. I'm a Catholic, obviously, and I would say that source of revelation is Jesus Christ. So you're not going to be able to answer the questions of the who of God, the heart of God, from either science or logic or rational evidence or some kind of, scientific pursuit. You're going to have to go to revelation, or you're going to have to go to your own heart, your own moral capacity to understand. It's a great question. Did I answer what you were thinking about?
You gave me an answer, and I thank you.
Sure.
Hi. If you accept everything you're saying about quantum cosmology,
yeah.
But at the same time, you're looking at what biblical scholars would say would be the timescales of the Bible, Genesis. They're order of magnitudes apart. How do you reconcile those two?
Well, basically, I'll just say this, and I don't want to get... as a Catholic, I'll just say I look at the Bible as not being a scientific tractate, to give an accurate physical description and explanation of the universe. I look at the Genesis narrative to be sacred truths that are necessary for our salvation. So, for example, I don't think the biblical author could have possibly understood or even written down the cosmological physical cause of the universe that we now understand from contemporary physics and science. But I do think that I need the Genesis narrative to at least get me to 4 sacred truths necessary for my salvation. Number one, right, because the Genesis author, right, he's interacting, the biblical author is interacting with the Gilgamesh epic and the other kinds of myths at his time. And so he has to respond to that. So the first thing, of course, is there's only one God. There are not many gods. That's important for salvation, and that's important in Genesis. Number 2, all the things of nature are not gods. There's not a sea god. There's not a star god. There's not a sun god. There's just God, and everything else is a creation of God. Number 3, matter is not bad in itself. Matter is good. God saw that the creation was good. And number 4, human beings are the pinnacle of creation. They are made in the image and likeness of God. Now, you're not going to get that out of science, but you are going to get that out of revelation. And so for my point of view, it is not necessary to reconcile, the scientific description with the description in the Bible, because I don't think the intention of God or the biblical author, from my point of view, right, I'm speaking as Catholic, that it was to give a complete, accurate scientific and physical description explanation of the universe. That being said, there have been two rather interesting articles, as you put it, they're magnitudes apart, that have a real basis in the general theory of relativity that try to explain this. And I'm trying to think of, it's a Jewish author, his name is, it's escaping me right now, but he actually, and this is true, I actually validated it myself by using the general relativity equations. Basically what he showed, you see when you have what's called mass density being very, very, very high, right? So if you have just a huge amount of mass density in a particular spot, the general theory of relativity requires that time slow down. So that at the first moment of creation, right, what you would call a day in our days today, and we don't have the same mass density of the universe that occurred 13.8 billion years ago. But what is the absolute case is time is traveling so slow within that system that one of today's days would be equal to 8 billion of today's years. And then, of course, the second day, when the mass density is much less, right, the second 24 hours, as it were, the mass density is less. So one day in that particular configuration within that universe would be worth only like 3 billion of our years today. Well, if you just keep adding it up, it actually comes out that 7 days is a pretty good accurate figure, to reach our era of the universe, which is basically a 0.5 redshift or greater universe. And so there is something to be said for, some remarkable parallels between physics and the Bible. And that's one of them. Another really remarkable parallel is the let there be light. I mean, the idea that light energy would precede everything else. I mean, where do you see this anywhere? Again, there's some remarkable coincidences in the physical description, the sacred description, but I don't feel that there has to be a complete equivalence. But again, if that's contrary to a doctrine that you are holding, then you would have to hold to your doctrine, and certainly not to my understanding of the Bible.
Thank you.
Sure. It's not Howard Smith. He might have written about it. It's a Jewish fellow. It's no, Lawrence Krauss. No way. I'll think of it in a moment. I'll get it. Other question?
Thanks for a fascinating presentation. I can only wonder what it would be like if you really let it all out. I wanted to ask, with the one part in so many trillions of parts, it would seem that the transphysical creator was setting things up for a long run, if you will.
Yeah, absolutely.
Yeah, so we stand so far down in line that only makes sense. I wondered if you saw physical arguments for the continued involvement of the creator with his creation.
Well, in science, of course, you cannot make that deduction because, of course, God is transphysical and science is dependent upon observational data. So you couldn't do it from science. But in philosophy, you could try to make such an argument. And my professor was Dr. Paul Weiss, and his professor and dissertation director was Alfred North Whitehead. And I can tell you that Whitehead did try to make, he had a secondary nature of God where he tried to make that argument, in what's called process philosophy. There's another set of philosophers who would vehemently disagree with that because they would require, and I have this proof on my website, magicenter.com, it requires that God be from all eternity transtemporal and would have to be an unrestricted act of thinking. Now, there's a very good proof of this, but I can't get into it right now. But the proof is there. If you go to magicenter.com, simply look at the ontological proof of God's existence. I mean the metaphysical proof of God's existence that's there on the website, and that comes from a philosopher by the name of Bernard Lonergan, Lonergan, in a huge, thick book called Insight, a study of human understanding. And in that book, Lonergan himself, was a physicist, mathematician, but he didn't make the argument on the basis of science. He made it on the basis of metaphysics, and you can take a look at that. And I think it's a strong argument for not only the existence of God, but an unrestricted act of understanding. Now, could an unrestricted act of understanding evolve per se in the way we evolve from state A to state B? No. It would have to be embracing the complete intelligibility of all being in itself, in its eternal now, if I can use St. Augustine's words.
Thanks very much.
Sure. But Alfred North Whitehead, if you're looking for that kind of argument, the process philosophers would be able to assemble one. And like I said, Paul Weiss was my teacher, so I certainly learned about Whitehead. Thank you.